Hello. Today I would like to show you how to identify different types of reactions. So if you'll recall, the different types that we have are synthesis, decomp, combustion, single replacement, double displacement or replacement, and combination. Did I cover all? Combustion. Okay, combustion. Sorry, I don't have all my notes out like I needed. You were given this and my resource sheet at chemistry formulas and equations. And on here is a nice little graphic to help you with the types of reactions. So we have synthesis, where you have two elements combined to form one. Decomp, or this is also called combination, where it's a reverse of a synthesis or combination, where one compound breaks up into two smaller compounds. Single, where one element takes the place of another. Double, where the positive parts swap places. Neutralization, which is the same thing as like a double, where the metal replaces a hydrogen and an acid to produce water and a salt. And combustion, where any carbon-containing compound reacts with oxygen to produce carbon dioxide and water. Okay? So again, you have this in my resource folder in Schoology. You can open it up and it has all the formulas. Okay. So let's look at these. So this first one, we have potassium chlorate is the only reactant, and we see that we make potassium chloride and oxygen. So notice it has one reactant, breaks down into two smaller ones, and so that is an example of decomposition. Okay. Here we have hydrochloric acid reacts with sodium hydroxide to produce sodium chloride and water. Okay, the fact that we have a acid and a base reacting to form water and a salt, and we know that from our activity series of metals, we look to see that sodium can replace the hydrogen in acids. So that's an example of a double displacement or neutralization. Okay. All right, here we have magnesium reacting with hydrochloric acid to produce magnesium chloride and hydrogen gas. So I know that anytime I have an element replacing another element in a compound, and we see that magnesium can replace the hydrogen in acids, so that's an example of a single. Here we have hydrogen reacting with oxygen to produce water. So I have two simpler substances combining to make one product, and that is an example of a synthesis or combination. Here we have aluminum reacting with nickel 2 bromide to produce aluminum bromide and nickel. So I see from my activity series list that aluminum can take the place of nickel, and it's one element replacing another, so that's an example of a single. All right, and then let me see. Oh, I don't have any combustion on here, but that's okay. So here we have aluminum reacting with oxygen to produce aluminum chloride. This is synthesis. Here we have sodium chloride breaking down to sodium and chlorine. We have decomposition. Here we have calcium chloride reacting with fluorine to make calcium fluoride and chlorine. And I know that from my activity series that fluorine can take the place of chlorine. Whoops, sorry. That fluorine can replace chlorine. And so this is a single. Here we have silver 1 nitrate reacting with potassium chloride to produce silver 1 chloride and potassium nitrate. Here we have the two positive portions. So this is positive, negative, positive, negative, positive, negative, positive, negative. And then we can see where the potassium and the silver swap places, and this is double. So we have nitrogen reacting with hydrogen to make ammonia and making one compound, so that is a synthesis. Here we have hydrogen peroxide, which is in that little brown bottle that you use to clean up your cuts. This is the reason why it's in a brown bottle, is because light actually breaks it down, and over time it will slowly decompose to form water and oxygen. Here we have ammonium sulfate reacting with barium nitrate to form barium sulfate and ammonium nitrate. Again, these are ionic or pseudo-binary ionic compounds, and we have the two positive portions swapping, and this is a double displacement. This ends up making an insoluble solid, and that's soluble, and that's why up here, wherever my other double is, the silver chloride is a solid, and that's why that works. Magnesium iodide reacting with bromine to make magnesium bromide and iodine. And again, I can see from my little list, bromine can replace iodine. And this is an example of a single. Here we have sulfite reacting with water to produce sulfuric acid. And this is an example of a synthesis. And then we have potassium chloride, zinc 2 phosphate reacting with zinc 2 to make zinc 2 chloride and potassium phosphate. Again, we have pseudo-binary and binary ionic compounds where the positive parts swap in a double displacement, making the zinc 2 chloride as a insoluble compound. Ta-da! And that's how you identify different kinds of reactions as to what type they are. Bye!